All right, so this question says a flying squirrel jumped from a tree branch and floated to the ground. The squirrel's height in meters above the ground, t seconds after jumping, is modeled by h of t. So the height of the squirrel over time is negative 2t squared plus 4t plus 30. Suppose we want to know the height of the squirrel above the ground at its highest point. Okay, that sounds cool. So what we're gonna do is number one says rewrite the function in a different form, factored or vertex, where the answer appears as a number in the equation. So what I'm gonna do is this function is written in standard form. I'm going to kind of factor it and write it in factored form. That's gonna help me. First thing I'm gonna do though is pull out the 2, and I'm gonna pull out a negative 2. This is gonna give me a starting term of just t squared, which I like a little more. T squared than 2t squared, the negative 2t squared. If I pull out negative 2 from 4, I'm gonna be left with negative 2t, and pull out negative 2 from 30, I'm gonna be left with negative 15. So this, I have rewritten the function by pulling out negative 2. I pulled out the common factor of negative 2. That's left me with negative 2 times t squared minus 2t minus 15. If you multiply that back out, it should give you the same as the original. What I can do now is I can factor this quadratic in the parentheses. So I need two numbers that multiply to negative 15 and add to negative 2. So that's going to be negative 5 and positive 3. So it's going to be negative 5, x minus 5, and then positive 3, x plus 3. So in parentheses, I've factored it as x minus 5, x plus 3, but I can't forget I still have the negative 2 in the front. So I've rewritten this equation. I took out the negative 2, and then what's left, I factored that into, and I wrote x, but it should be t. So I'm going to put it in here. It's negative 2 t minus 5 t plus 3. So this also tells me my two solutions are 5 and negative 3. As its highest point, how far above the ground was the squirrel at its highest point? So where was the highest point? Let's think about it. So I have a graph, and h of t is the height of the squirrel. T is time. I know I have solutions of 5 and negative 3. So 1, 2, 3, 4, 5, and negative 1, 2, 3. So what's the distance between 5 and negative 3? That distance is 8. So if I go halfway, that's going to give me the vertex. So the vertex is when x is 1. After 1 second, the squirrel reaches its maximum height. What is the height? Well, luckily we have a function. So if we know that 1 second has passed, we can plug in 1 for t, and then it will tell us what the height is. So it's going to be, I'll use the original function, negative 2 times t squared. So 1 squared is 1, plus 4 times 1 plus 30. So I have negative 2 plus 4 plus 30. That gives me negative 2 plus 4 is 2, plus 30 is 32. So I hope that is right. That's a pretty high number for meters. All right, doesn't like it. So let's get help on it. Oh, did I mess anything up? Probably not. It says the highest point was 32 meters above the ground. So this is probably fine. Yeah, so I've in doing these previously, it tells me about the different forms. I believe that if you multiply back what I have, you should get the original expression. So everything should be good here, and I believe this is right. Sometimes it marks this right, sometimes it doesn't. But I'm not gonna try to kind of finagle a different way because this way should work just fine. So I can check again, and I'll point. All right. So this says function g can be thought of as a scaled version of f of x equals x squared. Okay, I like that. So the blue here is f of x, and the g is a scaled version, and it looks like it's being like stretched up. It's narrower. Um, because on g of or sorry on f of x. So let's take a look on f of x. When x is 1, y is 1. It's squaring it. When x is 2, y should be 4. So we're squaring x. With g, something else is going on. So it's not, when x is 1, y is 5. It's 5 times that. So I think g of x, instead of just being x squared, I wonder if we actually multiply that by 5, because that's what's happening when you plug in 1 for x. It's not 1 squared, it's actually 5 times that because it's 5. So to test that, you could test that with 2. So what's going to happen is when x is 2, 2 squared is 4, y should be 20. So when x is 2, y should be way up here. And it actually looks like that graph, if I went to 20, 14, 15, 16, 17, 18, 19, 20-ish, it would sort of match up when at 220. Right, it's going in that right direction where x is 2, y is 20. So all that we're doing, if we go from the blue to the purple, you're just taking the value and you're multiplying it by 5. So when you input x, instead of getting 1, you get 5. Instead of getting 4, you get 20. And we're kind of stretching this function upwards. It's becoming more narrow. And it looks like here this one is 5 times x squared. So to find the output, it's similar to y equals x squared, but you actually would then multiply it by 5. All right, so this question says, rewrite the function by completing the square. Okay, so what I'm going to do is I'm going to start using completing the square as a method here. So we'd seen this at least once before, I think just once before in this. So what I'm going to do is I'm going to focus on the a and b terms. I'm going to isolate those. So I'm going to get 4x squared plus 12x. And then I want to get the 9 out of my face. I want to get it on the other side of the equation. So instead of equals 0, or instead of plus 9, I can think of it as plus 9 equals 0. I want to set this equal to 0 and solve. What I'm going to do is subtract 9 from both sides. So I'm just going to erase that, and I'll have this as a negative 9 for my first step. And I left the space just as I did last time with completing the square. I believe what I'm going to do is pull out the 4. So I'm going to make this 4 times x squared plus 3. Equals negative 9. So where I'm going to go from here is I'm going to complete the square within the parentheses. And hopefully this all kind of works out well. So it's going to be to complete the square within the parentheses, it's going to be x squared plus 3x. The x is still there. And half of 3 is 3 over 2. 3 over 2 squared is 9 over 4 plus 9 over 4. But to balance the equation, I'm not adding 9 over 4. I'm adding 9 over 4 times 4 because the 4 is being distributed. So that 9 over 4 times 4 is just 9 because the 4s would cancel out. So I am adding 9 to the left side. If I add 9 to the right side, that gives me 0. So I think that actually balances this out in like a weird, perfect way. Okie doke. So what I could do here is I can now write this as a perfect square. So I can write this as 4 times x plus 3 over 2 squared equals 0. And I think those are the numbers that are going to work here. I hope those are the numbers that are going to work here. So x plus 3 over 2, and then 0 will be the other one there. Oh my gosh, that worked. Sorry if it wasn't explained super well. I'm happy to clarify and do more specific quizzes if you guys have specific like lessons or question sets that you'd like me to do. All right, so we have here someone solving a quadratic equation, but it seems like they've made a mistake somewhere, and we just need to figure out where that is. Is that right? Yeah. So step 2 is missing, and it's asking what could she have written for step 2. So let's check it out. So what she has at the start is 1/5 times x plus 3 squared minus 2 equals 18. And the first thing she does is adds 2 to both sides. That gives us step 1. The next thing she should do is multiply both sides by 5. That's going to get rid of the 1/5. So that's going to give you x plus 3 squared equals 5 times 20 is 100. So this should be the next step. X plus 3 squared equals 100. So let's check it out. So I like C, x plus 3 squared equals 100. That matches what I have. All right. So for this question, it says let P equal 4x minus 7. All right, that's very nice. So P is 4x minus 7. Which equation is equivalent to 4x minus 7 squared plus 16 equals 4x minus 70? All right. So what we're going to do in this question is we're going to try to kind of rewrite this equation here, but instead of using x, we want to use P. So they set it up nice and easy for us where what's in parentheses, and when you see the other questions like this, when you see this in the tests or in the quizzes, typically whatever's being squared, that is P. That's what you're going to substitute in. So if I'm rewriting this equation, instead of 4x minus 7, I can now call it P. So P is squared. 4x minus 7 is squared, but it's now P plus 16. So I'm just rewriting the equation. But instead of x, I'm going to use, instead of like looking for x, I'm trying to take 4x minus 7 and replace it with P. So the weird thing on the right side is it looks like I don't see 4x minus 7. But if you think about this, you can kind of pull out a common factor here. So what I'm going to do is if you can pull out a 10, you're going to be left with 4x minus 7. So all I did is for the 40x minus 70, I took out the common factor of 10. That leaves me with 10 times 4x minus 7. So if you multiply the 10 back, you'll get 40x minus 70. But what this lets me do is rewrite the equation as p squared plus 16 equals 10p, because 4x minus 7 is p, which it told us right at the start. So right now, it looks like I have p squared. If I get everything on the same side, I'm going to have p squared minus 10p. I'll subtract 10p from both sides, plus 16, and I would set that equal to 0. That's if I subtract 10p from both sides. So it looks like answer choice is, it's not B, it looks like C, p squared minus 10p plus 16. So we're like getting all the terms on one side and setting it equal to 0. Okay. So this question says, Michaela and Grace were trying to solve the equation 4x squared minus 100 equals 0. Okay. Michaela said, I'll factor the left-hand side of the equation as 2x plus 10, 2x minus 10, and I'll solve using zero product property. I think that's seems like a good way to solve as long as she factored correctly. And then it says, Grace said, I'll isolate the x squared term by adding 100 and dividing 4 on both sides. And then I'll solve by taking the square root. So I think that definitely works. So what I want to do is kind of look at Grace's first. I think this is the more direct way to solve it. So she said isolate x squared by adding 100. So if we add 100 to both sides, that is going to isolate x squared. So it looks pretty good. So if I add 100 to both sides of this equation, I'm going to get 4x squared equals 100. And then Grace, so she added 100 and then divided both sides by 4. So that would just give you x squared equals 25 if you divide both sides by 4. Then Grace solves by taking the square root. So x is going to be the square root of 25, which is plus or minus 5. It's either 5 or negative 5. So those are the two answers. So I like that way of solving. It's a really direct way to solve. What Michaela does, so I'll use a different color, Michaela factors. So all I'm going to do is just kind of make sure that this 2x plus 10 times 2x minus 10, does that actually equal 4x squared minus 100? If I do 2x times 2x, that's 4x squared. If I do 2x times negative 10, that's negative 20x. But then I have 2x times positive 10, so that's plus 20x. That is going to get rid of all the x's for me. And then positive 10 times negative 10 is minus 100. So the reason I did that, the negative 20x and the positive 20x cancel out. So you're left with 4x squared minus 100. So it's the same thing. So what I'm saying is that what Michaela did, factoring as 2x plus 10 times 2x minus 10, that is equivalent. That is the same thing as 4x squared minus 100 if you multiply it out. So Michaela, that's a good way to solve it, is factoring. So I think we saw that earlier in the test here. Factoring is a good way to solve. And what you can do is set each factor equal to 0. So 2x plus 10, set that equal to 0. So this is what Michaela decides to do. And then 2x minus 10. The two answers you're going to get are 5 and -5. So it turns out both of these ways work out well. If you solve these for x, on this one you'll get -5, and on this one you'll get +5. So you get the same two answers either way. So I think both Michaela and Grace's methods should work just fine.